Welcome to the GED training course on Intercept Spacer Corner Quality. While this demonstration is being performed on a GED Intercept 2.5 spacer frame machine, this lesson applies to all Intercept models producing ultra stainless steel spacers. This lesson on corner quality will focus on how to use a corner fold force gauge and spreadsheet. Here we will learn the purpose of the corner fold force gauge, how to use the gauge, how to enter data in the Excel spreadsheet, and how to interpret the data using the troubleshooting guide. The purpose of the fold force gauge is to ensure the corner quality is good and to help extend the life of the corner tooling when producing ultra stainless steel spacers. GED recommends this is checked at least once per shift and whenever corner issues arise. With ultra stainless steel spacers, the force required to fold the corner is a good indicator of the quality of the folded corner. The key factors that affect corner fold quality also affect corner fold force. These factors are web impression, penetration depth, corner punch depth from the edge of the material, and crimping. Note, the fold force gauge is used only to evaluate ultra spacers. No correlation has been established for the force required for thin plate spacers. A full explanation of the fold force gauge and how it is used is outlined in the GED Intercept User's Guides. See the list below for the appropriate instruction manual. To access these, on the machine's PC, from the WinFrame main menu, select Help, then Online Manuals. Use the index in the manual to navigate to the fold force gauge section. If you need a copy of this spreadsheet, please contact the training coordinator at GED. The fold force gauge measures the force required to fold the spacer frame corners. This provides an objective measure of the factors that affect corner fold quality, and thus removes subjectivity and opinion from the setup procedure. You can take periodic samples of the fold force to monitor your process and make adjustments before defects occur. After a process adjustment is made, the resulting effect on the fold force can quickly be measured and understood. There are two main criteria that define acceptable fold force data. First, all fold force values should be within the range of 40 to 60 ounces, ideally between 45 to 55 ounces. And secondly, the range between the highest and lowest measured values should be no greater than 7 ounces. The corner fold force gauge consists of a digital force gauge that is mounted on a linear slide. The crank handle rotates a screw that moves the force gauge along a linear rail. The plastic contact block is mounted on the force gauge. There are two hold-down bars that hold the spacer close to the base plate of the assembly. Two shoulder bolts support the spacer and locate it near the center of the contact block. There are two sets of tapped holes in the base plate. If the spacer width is ½ inch or less, the shoulder bolts should be located in the higher set of holes. If the spacer width is larger than ½ inch, the shoulder bolts should be located in the lower set of tapped holes. The force gauge control panel has 4 keys as shown below. To turn the unit on, press the 0 key. To turn the unit off, press the 0 key and hold for 2 seconds. To reset the display, press the 0 key. If the unit is idle for a period of time, it'll turn off automatically. Set the mode to measure and display the maximum compression force. Do this by pressing the max key until the lower left corner of the display appears as shown here. Press the units key until the display reads OZ for ounces as shown here. In addition to the fold force gauge, there's an Excel spreadsheet titled Fold Force Gauge-Ultra SS, which looks like this. When recording the values, use a spreadsheet and it will automatically calculate the averages, minimum, maximum, and range. These values, as well as the pre-charge values, are conditionally formatted to match the interpretations in the tables 2, 3, and 4. Only corners 2, 3, and 4 need to be used to determine the average, minimum, maximum, and range. You can still record data from corner number 1, but that data is kept separate from corners 2, 3, and 4. This is because of its proximity to the leading edge, which has been swedged in the cutoff process. The fold force of the first corner may be slightly affected because of this, and is therefore kept separate from the other 3 corners. Fill in the information at the top of the spreadsheet. This data may be useful in tracking the life of the tooling. Disregard the tab Precharge value, as the Intercept 2.5 does not have a regulator for precharge on the tab, since the machine comes standard with Corner Plus tab tooling. Turn the crank handle counterclockwise until the plastic contact block is behind the base plate. The crank should turn freely without binding. If necessary, loosen the split collar closest to the force gauge and back it off slightly until there's no binding, and then retighten the split collar. Place a sample spacer, a 12 by 12 is recommended, so that it rests on the shoulder bolts and is below the hold-down bars. The corner notch must be precisely aligned with the edge of the base plate as shown in the photos below. Rotate the crank handle clockwise at a medium speed until the force value on the display is no longer increasing. The maximum force will be registered just at the point where the corner begins to fold. There is no need to continue any further. Record the value shown on the display in the spreadsheet. Press the tab button to advance to the next corner. Rotate the crank handle counterclockwise until the contact block is behind the groove in the base plate, providing clearance for the next spacer. Press 0 to reset the display. Repeat the same process on the next corner to be tested. Once the readings have been recorded for corners 1, 2, 3, and 4, flip the spacer end for end to test corner number 4. This way the rest of the spacer is not hanging in mid-air, putting a twist on corner number 4, which could influence the readings. When you have tested 4 spacers, review the values for the average, minimum, maximum, and range in the corner punch column and compare these values to tables 2 and 3. Ideally, you want the average, minimum, and maximum values to be between 45 to 55 ounces, but anything between 40 and 60 ounces is good. The range should be less than 7, but ideally less than 5. If you have values outside of this range, then look at the Troubleshooting tab to find a similar scenario. When you find a match, read over the evaluation and suggested solutions to resolve the issue. Remember too from the previous lesson that if the crimp pins hit too hard as shown here, this can impact the fold force values. While the crimp pins may or may not leave a slight mark or indentation on the side of the spacer, you should always check the display on either side of the corner and compare it to the display between the 2 corners. As you saw here, one side of the corner was splayed in at -46.5 thousandths. Using the knowledge you have gained from this course, select the most logical solution and make the necessary adjustments to produce in-spec quality corners while minimizing excessive wear on the tooling. Run more samples and repeat the fold force test until the spacers meet the recommendations. Thank you for participating in the lesson on the corner fold force gauge. Please complete the other lessons in this GED training course shown here.